Welcome back to the Walnut. In this session, I am going to discuss a very important concept from the topic numbers. This is the unit digit of the power of a number. It's the most frequently testing type of question in almost all the various types of competitive exams. While we are considering the unit digit of such a kind of expression or a number in the form a raised to n or the power of a digit or a number, we can consider some of the examples here. Here, the first one. What is the unit digit of 120 raised to 25? How to find out it? So, unit digit of 120 raised to 25. Can you guess which will be the unit digit of such an expression? Hopefully, you all are really confident to find out what is the unit digit of such a number. Because we know that the unit digit of this base number 120 is 0. So while we are considering such a kind of expression 120 raised to 25, this is nothing but we are simply multiplying the number 120 in 25 times. So 120 into 120 into 120, etc. up to 25 times. What will be the resultant unit digit? You can easily conclude that's nothing but 0. Because here we just consider the first part we just consider. If we need to find out the unit digit of 120 raised to 25, this is simply 0 raised to 25. What is 0 raised to 25? Its unit digit is 0. So you just think about which are the other numbers which will provide the same kind of simple result. Means we know that 0 raised to any number that will end in 0 itself. Which are the other such type of numbers? We can easily conclude. We just consider another one example. Suppose we just consider the number 1. 1 raised to any number. What will be the unit digit? It's always 1. Can you guys other some examples? Yeah, definitely, you got it in your mind. That is another such number 5. Think about it. 5 raised to any exponent. It will end in 5 itself. One more. One more number is there. So that is 6. 6 raised to any exponent, that will end in 6. Means while you are facing such a kind of question, it's not mandatory you have to consider the remaining part of this number. It's not a relevant part, only you have to focus on the unit digit. Now we can move to the next such type of question. Here we have to find out the unit digit of 324 raised to 632. How to reach the conclusion? So we can again reduce the task like this. This is nothing but unit digit raised to 4 raised to 632. Got it? 4 raised to 632. Then after that, how to make such a conclusion? Here 4 raised to 632, we know that simply it's 632 times we have to multiply the digit 4. So we are doing that kind of a refer here. What will be the pattern here? Now we are considering the pattern of unit digit. Suppose we just consider 4 raised to 1. What will be the unit digit? So that is 4 itself. We are moving to the second set, that is 4 square. What will be the unit digit here? This is 6. Only you have to focus on the unit digit. We know that 4 square is 16. But we are considering only the unit digit, therefore consider only 6. Suppose if we are moving to the third such exponent, this is 4 cube. What is 4 cube? That is 64. Or simply we know that if you are multiplying this 6 by 4, think about the unit digit. That is again 4. Once you will get such a kind of pattern, we can easily conclude if it is 4 raised to 4, that is nothing but this 4 into 4, that will be equal to 6. We are considering only the unit digit. So we got a pattern here, a repetition pattern here. This is 4, 6, 4, 6. Such kind of a pattern we got. That's a very important and interesting point related to unit digit of such a kind of expression is for all the digits, or the digits in the sense while we are considering this kind of an expression, only think about single digit values, they are exponents. How many single digit values there? 0 to 9. All these 10 digits has its own pattern of cyclicity of this unit digit. Here, this value will repeat 4, 6, 4, 6, 4, 6. So, how we can conclude this one? So, we can conclude here, if it is 4 raised to any odd exponent, unit digit is always 4. Instead, 4 raised to any even exponent, unit digit will be 6. So, this is the conclusion here. So, we already discussed the 4 set of values like this. 0 raised to any exponent, 0, 1 raised to any exponent, 1, 5 raised to any exponent, 5 and 6 raised to any exponent, 6. And this is the second such type of numbers. Can you guess? Which are the other such type of numbers which are satisfying this kind of two different types of unit digit? So there is one more such number. Before going to that value, we just conclude this question. This is 4 raised to 632. So we concluded like this. If it is 4 raised to an odd exponent, unit digit will be 4. Instead of 4 raised to an even exponent, unit digit will be 6. Here, observe this value. This is even. Therefore, what will be the conclusion? 4 raised to an even exponent, unit digit will be 6. Got it clearly? Yeah. Let us come to this point, which is another number that will provide such a kind of pattern. Can you guess? Can you do it by mind? So there is only two different unit digit pattern. So that is nothing but 9. So in the similar way, we can conclude 9 raised to an odd exponent, its unit digit is 9. And 9 raised to an even exponent, its unit digit will be 1. So this is the next such number. Now we are moving to another one example. This is 182 raised to 503. Now you are quite familiar to reach the conclusion. Only the difference in this base. Here again, we can reduce the task. This is unit digit of 2 raised to 503. Here again, we are framing a pattern of 2. So we are considering the pattern of 2 here. 2 raised to 1. What is the unit digit? 2 itself. 2 square, only think about the unit digit, that is 4. 2 cube, what is the unit digit? That's 8 itself. And 2 raised to 4. So 2 raised to 4 is 16, or otherwise you just simply multiply this 8 by 2. You will get 16. You just write only 6. What will be the next step? 2 raised to 5. 2 raised to 5 is nothing but we just multiply this 6 by 2 while we are considering the part of that unit digit operation. This is 2 into 6. It's become again 2. So what the pattern will repeat like this? It's a repetition pattern, or this is the cyclicity. We can conclude the unit digit are 2, 4, 8, 6, 2, 4, 8, 6. The pattern will repeat infinitely. Clear? So next step. First we concluded that for the case of 2, there are 4 distinct unit digits. And think about this exponent. So where these exponents will come in this counting, 1, 2, 3, 4, 5, 6, 7, 8. Whenever the exponent is a multiple of 4, always the unit digit is 6. So we are checking, while we are counting like this, where this 503 will end. So for catching that thing, we know that before 503, which is a multiple of 4. Why we are considering the multiple of 4? Because whenever the exponent is a multiple of 4, that will end in this place. So here we know that 500 is a multiple of 4 immediately less than 503. So 2 raised to 500 will be, provide the unit digit 6. So 501 will be here, 502 will be here, 503 will be here. So therefore, this will be the answer for this question. So we can conclude here the answer is 8. So what is the step we have proceeded here? So first we found this kind of pattern of unit digit. Then we are simply considering 503 divided by this 4 distinct unit digit, which will be the remainder. Here we got 3 as the remainder, therefore third value from the pattern. In the similar way, we can consider the last example too. So this is, again we can reduce the task like this. This is unit digit of 7 raised to 462. Again we are finding the pattern of 7 here. 7 raised to 1, that is 7 itself. 7 square, it's equal to 9. Don't forget 7 square equal to 49, but we are considering only the unit digit, therefore that is 9. 7 cube. For finding the unit digit easily, you just consider 9 into 7, which will be the unit digit. 9 into 7, here we know that that is 63, so you can conclude 3 as the unit digit. And 7 raised to 4, instead of thinking which is the actual value of 7 raised to 4, you just simply multiply this 3 by 7. So 3 into 7, that's equal to 1. So that's a lucky step, because whenever you will get in such a kind of repetition pattern, 1 is a member or output over there, no need to go further, because we know that the repetition will start immediately after this step. Don't forget, it's not mandatory to get a 1 for a repetition. In the case of 2, it ends in 6. So when we will get 1, then the repetition will start immediately. So here we also got the pattern like this, 7, 9, 3, 1. So there are 4 distinct unit digits. Again, we are checking the same way of approach, 462, where it will come. So immediately less than 462, which is a multiple of 4, that is 460. So therefore, after this 460, 2 more there. Therefore, second value from the pattern. This is first value, this is second value, therefore its unit digit is 9. This is the simple and the most effective way to find out the unit digit of any kind of values in this format, a raised to n. So this is the basic idea of finding the unit digit. Thanks for watching.